Hi everyone, and we have completed up to 6 lectures, right? Okay, so this is the 7th lecture, and we are dealing with coordinate systems, right? So we are dealing with third chapter, that is coordinate systems. So we have completed rectangular coordinate system. Now we have started cylindrical coordinate system. So in the previous lecture, I have explained what is rho, what is phi, and what is z in cylindrical coordinate system. I have explained what is rho and what is phi and what is z, and also I have explained what are the differential lengths along rho. The differential lengths along rho is d rho, a rho cap, and the differential length along phi is rho d phi, a phi cap, and the differential length along z is dz, az cap. Okay, so these things we have seen, and also we have seen the ranges of rho, phi, and z. So and also we have seen what happens if rho varies, right, and what happens if phi varies, and what happens if z varies. So all these things we have seen in the previous session, right? Okay, so in this lecture we will see how we can convert or how to represent rho, phi, z in terms of cylindrical coordinates. We will see how to represent rho, phi, z in terms of what? In terms of rectangular coordinates. Understood? So that's what we are going to see now. See here. So how to represent the cylindrical coordinates in terms of what? In terms of rectangular coordinates, right? And also we will see how to represent rectangular coordinates in terms of cylindrical coordinates. Both we are going to see, right? Okay. So I am copying this figure. Right. So in cylindrical coordinates, what are the coordinates here in cylindrical coordinate system? That is rho, phi, and z, right? Okay. So we know that z is same as what here? Z is same as z only, right? I have already told that the definition of z will remain same whether in a cylindrical coordinate system or in rectangular coordinate system, right? So that means here z is same as what here? Z is same as z only, right? So now we try to write represent rho in terms of rectangular coordinates and phi in terms of rectangular coordinates, right? Okay, so here there is no need to remember anything here, just we will follow the definitions of rho and phi, right? So what is rho here? Rho is nothing but the normal distance from the axis of the cylinder to any point on the surface of the cylinder. So here this is the axis of the cylinder, right? This z axis is nothing but axis of the cylinder, right? Okay, so the normal distance from the axis of the cylinder to any point on the surface of the cylinder is called as what? Is called as rho, right? We want to represent that rho in terms of rectangular coordinates. So see here, so here I am representing this point. So this point is lying along what? This point is lying along z axis. So I can represent this point as a 0, 0, z, right? This point I am representing as 0, 0, z, or you can consider z1, or otherwise simply you can consider z, right? 0, 0, z. Next, this point here, what is this point? So this point, let us say this point is lying somewhere in 3-dimensional space, somewhere here in 3-dimensional space. So this point will become what here? This point is, let us say, x, y, okay. See here, as you move from this point to this point, z value is not going to change. Yes or no? Z will remain same, right? Okay, so x, y, z. This point is nothing but x, y, z, right? Okay. See these 2 points 0, 0, z and x, y, z are lying in this plane only. Understood? So the z value is not going to change from here to here, right? Okay. Okay. So as you move from here to here, z value is not going to change. So this point I am considering as x comma y comma z, and this point is 0 comma 0 comma z. Right. So now rho is nothing but what? Rho is nothing but the normal distance from the axis of the cylinder to any point on the surface of the cylinder. So which means the distance from 0 comma 0 comma z to x comma y comma z is nothing but what? Is nothing but rho. So what is the distance between these 2 points here? The distance between these 2 points is nothing but rho. So you can write rho as what? Rho as square root of x minus 0 whole square, that is x square, plus y minus 0 whole square, that is y square, plus z minus z whole square, that is 0 square. Okay. So rho is equal to what? Square root of x square plus y square. Right. Next 5. Next 5. So now see here. Here I am considering one point here. So the normal distance from the z axis to this point is nothing but what? Is nothing but rho. And the angle between this x axis and rho is nothing but what? Is nothing but phi. Right. Now here I am drawing separately the diagram here. So here I am considering x axis, and here I am considering y axis, and between x axis and y axis you are having rho. Right. So between x axis and y axis you are having rho. Okay. And the angle between x axis and rho is nothing but what? Is nothing but phi. Right. So if you observe, rho is neither along x nor along y. Right. So now you can resolve this rho into two components. One is along x, another one is along y. So the component of rho along x. So the distance from here to here is nothing but x, and the distance from here to here is nothing but, let us say, y. Right. Okay. So if you drop your normal from head of rho onto x axis, you are going to get the component of rho along x. So let us say the component of rho along x is nothing but x. Right. And this is nothing but what? This is nothing but the distance from here to here is nothing but y. Understood? So now from this right angle triangle, so this x is equal to what here? This distance, how you can write? This is the hypotenuse side, this is the adjacent side, and this is the opposite side. So you can write x as what? X is equal to rho cos phi. Right. So this rho cos phi is the x component of rho, and this y is nothing but what? Y is equal to rho into what? Rho into sin phi. This opposite side will become rho sin phi. This adjacent side will become rho cos phi. Right. Okay. Okay. So from this right angle triangle, we got x equal to rho cos phi and y equal to rho sin phi. So now if I take y by x here, what you are going to get? You are going to get tan phi. So therefore phi is equal to what? Phi is equal to, you are going to get tan inverse of y by x. Okay. So this is how we can represent phi in terms of what? In terms of rectangular coordinates. So here phi is equal to what? Phi is equal to tan inverse of y by x. Right. Okay. Okay. So this is the representation of rectangular coordinate, cylindrical coordinates in terms of what? Rectangular coordinates. So rho we can represent it as square root of x square plus y square. Phi you can represent it as what? Tan inverse of y by x. Z will be same as z. Understood? Okay. Okay. Now similarly we try to represent the rectangular coordinates in terms of what? In terms of cylindrical coordinates. So it is very easy here, it is very simple. See here. So you have to represent x in terms of cylindrical coordinates, you have to represent y in terms of cylindrical coordinates, and z will be same as what? Z will be same as z only. Isn't it? Right? Okay. Okay. So there is no need to do again here. So here itself we got the x value in terms of cylindrical coordinates. So if you observe here, what we got here? X is equal to what? X is equal to rho cos phi. That means the component of rho along x is nothing but rho cos phi. The component of rho along y is nothing but rho sin phi. So x is equal to rho cos phi. Y is equal to what? Y is equal to rho sin phi. Understood? So you can directly write that one. So x is equal to what? We can represent x is equal to rho cos phi, and y is equal to what? Y is equal to rho sin phi. So in this manner we can represent the rectangular coordinates in terms of what? In terms of cylindrical coordinates, right? Okay, okay. So I hope this is crystal clear, right? Okay, okay. So for example, if I have given 3 comma 4 comma 5 here, if I have given 3 comma 4 comma 5 and ask you to convert or represent so represent 3 comma 4 comma 5 in terms of what? In terms of cylindrical coordinates. So represent 3 comma 4 comma 5 in terms of cylindrical coordinates. If I ask you this, what you have to do? So this is x, right, and this is y, and this is nothing but z. So cylindrical coordinates are nothing but rho, phi and z. So rho in terms of rectangular coordinates is nothing but square root of x square plus y square, which is equal to square root of 3 square plus 4 square, which is equal to 5. Next, phi is equal to what? Tan inverse of what? Tan inverse of y by x, so that is 4 by 3, and z is same as z, so that is z is equal to 5. So in this manner you can simply represent the rectangular coordinates in terms of cylindrical coordinates. Understood? Okay. If they have given cylindrical coordinates and asked to represent it in terms of rectangular coordinates, then you have to apply this one. Understood? Okay, okay. So I hope it is crystal clear, right? Next, see here, see if I consider rectangular coordinate system here, let us say this is x axis and this is y axis and this is z axis, right? If I consider a rectangular coordinate system, then if I represent some point here, let us say some point I am representing, so the direction of, let us say the direction of ax cap, the direction of ax cap at this point will be always parallel to what? Will be always parallel to x direction. Understood? The direction of ay cap will be always parallel to what? Always parallel to y axis. The direction of az cap will be always parallel to what? Always parallel to z axis. So whatever the point you can take here, whatever the point you can take in rectangular coordinate system, okay, so the direction of ax cap will be always parallel to x axis, the direction of ay cap will be always parallel to y axis, the direction of az cap will be always parallel to z axis. So that means the directions of ax cap, ay cap and az cap are fixed. Yes or no, in rectangular coordinate system. See, if I consider somewhere here, some point here, so the direction of ax cap will be always parallel to what? X axis, the direction of ay cap will be always parallel to y axis, the direction of az cap will be always parallel to what? Z axis. Understood? So whatever the point you take in rectangular coordinate system, the directions of ax cap, ay cap and az cap are fixed. So the direction of ax cap is always parallel to x axis, the direction of ay cap is always parallel to y axis, the direction of az cap is always parallel to z axis. So their directions are fixed in case of rectangular coordinate system. Understood? Now coming to cylindrical coordinate system here, So if I consider the cylindrical coordinate system, let us consider sorry, cylindrical coordinate system, right? So this is z axis and this is x axis and this is y axis, right? Now if I consider arrow cap direction here, so let us say this point, at this point, the direction of aero cap is going to point in this direction, isn't it? Okay, this is rho, right? The normal distance from the axis of the cylinder to any point on the surface of the cylinder is nothing but rho. So aero cap is going to point in this direction. Now if I consider some point here, okay, so the normal distance from this axis of the cylinder to this point is nothing but rho. The direction of this rho at this point is pointing in this direction, that is aero cap. Now if I consider some point here, so the normal distance from the axis of the cylinder to this point is nothing but rho. The direction of aero cap is going to point in this direction. Now if you observe here, as I move from this point to this point, the direction of aero cap is changing or not? Yes or no here? So at this location it is pointing in this direction, at this location it is pointing in this direction, at this location it is pointing in this direction, and if I consider at this location it is going to point in this direction. If I consider at this location it is going to point in this direction. If I consider at this location, so aero cap is going to point in this direction. If I consider at this location, aero cap is going to point in this direction. Understood? Okay, so that means if you consider a cylinder, so at this location aero cap is pointing in this direction. So as you move along the circumference of the circle, the direction of aero cap is changing or not? Yes or no here? So at this location it is pointing in this direction. As you move along the circumference of the circle from this point to this point, at this location it is pointing like this, at this location it is pointing like this. Yes or no? So as you move along the circumference of the circle, the direction of aero cap is changing. The direction of aero cap is changing. It is not fixed, right? So it is changing as you move along the circumference of the circle. So which means the direction of aero cap is going to change as you move along the circumference of the circle. So as you move along the circumference of the circle, what is going to change? Phi is going to change. So which means the direction of aero cap is going to depend upon what? Is going to depend upon phi value. Understood? Okay, so when phi is equal to 0, the direction of aero cap will be different, and when phi is equal to 90 degrees, the direction of aero cap will be different. When phi is equal to 180 degrees, the direction of aero cap will be different. Understood? Okay, so the direction of aero cap is going to depend upon phi. So that's what we can conclude, right? Next, one more thing. Now if you consider a phi cap here, so a phi cap is nothing but what here? The tangent drawn at this point to this circle. Understood? Okay, so a phi cap at this location here, if you want the a phi cap, what you have to do? Just draw the tangent at this point here. So if you draw the tangent to this point, at this point it is going to point in this direction, a phi cap. And if you draw the tangent at this point, it is going to point in this direction. So if you draw the tangent at this location, it is going to point into the board. A phi cap is going to point into the board. And if you draw the tangent at this location in anti-clockwise direction, right? We know that the direction of a phi cap will be in anti-clockwise direction. So if you draw the tangent at this location, it is going to point in this direction. If you draw the tangent at this location, it is going to point in this direction. So that is here it will come out of the board here. It will come out of the board, right? And here at this location, the direction of a phi cap is going to point in this direction. Understood? Okay. Okay. So as you move along the circumference of the circle here, the direction of a phi cap is also what? Is also changing. The direction of a phi cap is also changing. So that means the directions of aero cap and a phi cap are going to depend upon what? Are going to depend upon phi. Right? As you move along the circumference of the circle, the direction of aero cap is changing, and also the direction of a phi cap is also changing. So that means the directions of aero cap and a phi cap are going to depend upon what? Are going to depend upon phi values. Understood? Okay. Okay. So now see here. So here in rectangular coordinate system, the directions of the unit vectors are fixed. Yes or no? Ax cap will be always parallel to x axis, ay cap will be always parallel to y axis, az cap will be always parallel to z axis. Whereas in cylindrical coordinate system, the direction of aero cap and the direction of a phi cap are changing as you move along the circumference of the circle. So which means the directions of aero cap and a phi cap are depending upon the phi values. Understood? And what is the direction of AZ cap here? AZ cap will be always what? AZ cap will be always parallel to what? If you consider this point, AZ cap is going to point parallel to Z direction. Understood? So if you consider here, it is going to point parallel to Z. It is going to point parallel to Z. It is going to point parallel to Z. Parallel to Z. Parallel to Z. Parallel to Z. So whatever the point you can take here. So whatever the point, not only here, whatever the point you can take. Okay. So the direction of AZ cap will be always what? Will be always parallel to what? Parallel to Z axis. Parallel to Z axis. Understood? Okay. So the direction of AZ cap will be fixed, whereas the direction of aero cap and a phi cap are going to depend upon phi. Right? Okay. Okay. Yeah. So now here, how to determine the dependency of aero cap and a phi cap on phi. Okay, so that's what we are going to see now, right? So we will see first how to represent this aero cap in terms of phi. Aero cap, right? Okay, okay. So now see here. So I will tell you two methods here. So you can follow any of these methods, right? Okay. So the first method, see here, the first method. So here I am representing the small differential length dl bar, the small differential length dl bar in terms of rectangular coordinates. That is, dl bar is equal to dx ax cap plus what? Plus dy ay cap plus what? Plus dz az cap. Right. So I am representing a small differential length dl bar is equal to what? Is equal to dx ax cap plus dy ay cap plus dz az cap. In rectangular coordinate system I have represented. Okay, okay. So now see here. So what I am going to do here is I am going to represent this small differential length. This small differential length dl bar. I am going to represent this small differential length dl bar by varying only rho. By varying only rho. So that means this is rho here. This is rho. Let us say this is rho. Understood? Okay. Okay. So if I move along rho here, if I move along rho, okay, if I am moving only along rho, then how I can represent the differential length here? The differential length dl bar, I can represent it as what? I can represent it as d rho aero cap or not? Yes or no here? Yes or no? So I am considering a small differential length. I am considering a small differential length along rho. So the small differential length along rho, I can represent it as what? I can represent it as d rho aero cap. So which means I am representing dl bar. I am representing dl bar by varying only rho. By varying only rho. Understood? So that means as I move along rho, what is the differential length I am going to get? That is nothing but d rho aero cap. Understood? So on LHS side, what I have done? I have determined the differential length dl bar by varying only rho. So that is nothing but what? That is nothing but d rho aero cap. Understood? Now on RHS side also, you have to determine dx. You have to determine dx by varying only rho, and you have to determine dy by varying only rho, and also you have to determine dz by varying only rho. Why here? Because on LHS side I have determined the small differential length dl bar by varying only rho. So that is nothing but d rho aero cap. On RHS side also I have to do the same operation. That is, I have to represent dx by varying only rho, and dy by varying only rho, and dz by varying only rho. So how we can do that? How we can do that? See here, just now we have seen how to represent the rectangular coordinates in terms of cylindrical coordinates. So just now we have seen that x is equal to what? X is equal to, so here I am writing, okay, so x is equal to rho cos phi, right? And we have seen that y is equal to what? Y is equal to rho sin phi, and z will be same as what? Z will be same as z. So you have to determine dx by varying only rho. So that means you have to differentiate on both sides with respect to what? With respect to rho. right? If you differentiate on both sides with respect to rho, what you are going to get? You are going to get dx by d rho is equal to what? Is equal to cos phi. So from here dx is equal to what? Dx is equal to d rho into cos phi, d rho into cos phi. Understood? So this is dx by varying only rho. Next, similarly, we have to determine dy by varying only rho. So if you want to determine dy by varying only rho, what you have to do? You have to differentiate on both sides with respect to rho. So if you differentiate with respect to rho, you are going to get what? Dy by d rho is equal to what? Is equal to sin phi. If you differentiate RHS with respect to rho, what you are going to get? D by d rho of rho sin phi is nothing but what? Sin phi only, right? Okay. So dy is equal to what? Dy is equal to d rho into what? D rho into sin phi. Now here z is same as z. So here z is not going to depend upon rho. So that means dz by d rho is equal to what? Is equal to 0. Therefore dz is equal to 0. dz is equal to 0. Understood? Now just substitute this dx value, and dy value and dz value in this expression. Then you are going to get what? Then you are going to get here, you are going to get d rho cos phi ax cap plus what? Plus d rho sin phi ay cap. Dz will be what? Dz will be 0. Now if you observe on both sides, d rho will get what? D rho will get cancelled. So therefore we got the expression for what here? Therefore we got the expression for a rho cap. So a rho cap is equal to what? A rho cap is equal to cos phi ax cap plus what? Plus sin phi ay cap. Okay, so cos phi ax cap plus sin phi ay cap. So this is the unit vector along rho. So if you observe this unit vector along rho, it is depending upon what? It is depending upon phi or not, right? Okay, so when phi is equal to 0 here, if you want you can check that when phi is equal to 0, a rho cap is equal to what? Put phi equal to 0 here, cos phi will become 1, sin phi will become 0. So a rho cap will be equivalent to ax cap when phi is equal to 0, right? So if I consider the point here, some point here, so this is nothing but what? This is nothing but rho, right? So whenever rho is along x direction, phi is equal to what? Phi is equal to 0 degrees. Whenever phi is equal to 0 degrees, a rho cap is pointing in which direction? A rho cap is going to point along ax cap direction. So that's why a rho cap will be equivalent to what? A rho cap will be equivalent to ax cap when phi is equal to what? When phi is equal to 0 degrees. Right. Similarly, when phi equal to 90 degrees here, that means if I consider a point along y-axis, okay, so the distance from here to here, the normal distance from here to here is nothing but what? Is nothing but rho. So this angle phi is equal to what? Is equal to 90 degrees. Right. Okay. So now at this location, what is the direction of rho here? The direction of rho is pointing along y direction. Understood? Okay. Now substitute here in this expression, substitute phi equal to 90. So here substitute phi equal to 90. What you are going to get? Cos 90 will be 0, sin 90 will be 1. So a rho cap will be equivalent to what? Ay cap. So at this location, phi is equal to what? Phi is equal to 90 degrees. Here what you are getting here? A rho cap is equivalent to what? Is equivalent to ay cap. So like that, at any point here, you are going to get what? You are going to get the direction of what? Direction of a rho cap. Right? Okay? Okay. So this is how we can determine a rho cap. What we have done here? We have written the differential length, right, in rectangular coordinate system. Then what we have done on LHS side, what we have done? We have determined the differential length by varying only rho. So by varying only rho, if you try to determine the differential length, we got it as what? D rho, a rho cap. Okay, so whatever the operation we have done on LHS side, the same operation you have to do on RHS side also. So which means you have to determine dx by varying only rho, and you have to determine dy by varying only rho, and also you have to determine dz by varying only rho. Right. So from that we got the expression for what? A rho cap. Right. So this is one method. So similarly with the help of this same method, you can determine what? You can determine for a phi cap also. Right. Okay. Okay. So next we try to determine a phi cap, right? The same thing here, follow the same procedure. So here first write down the differential length dl bar is equal to what? Is equal to dx ax cap plus what? Plus dy ay cap plus what? Plus dz az cap plus dz az cap, right? Okay. So now what you have to do? So you have to determine the differential length on LHS side. You have to determine the differential length by varying only phi. So by varying only phi, what is the differential length you are going to get? If you vary phi, what is the differential length you are going to get? Is nothing but rho d phi a phi cap. We know that one. Yes or no? It is nothing but the differential arc length along phi, right? So we will get the differential length. By varying only phi. The differential length that we are going to get is nothing but what? Is nothing but rho d phi a phi cap on LHS side. So on RHS side also we try to determine dx by varying only phi, and dy by varying only phi, and dz by varying only phi. So how we can determine that? So we know the relation. So that is x is equal to what? X is equal to rho cos phi, and okay, I'll write here itself. Okay, so here, so x is equal to what? X is equal to rho cos phi. Y is equal to what? Y is equal to rho sin phi. Z is same as what? Z is same as Z. Follow the same procedure. Whatever the procedure we have followed to determine aero cap, the same procedure you have to follow here, right? Okay. So this is LHS side. So on RHS side also you have to determine what? You have to determine dx by varying only phi. Here you have determined differential length by varying only phi. On RHS side also you have to determine dx by varying only phi, dy by varying only phi, dz by varying only phi, right? So what you have to do in order to determine dx by varying only phi? What you have to do here? So you have to differentiate on both sides with respect to phi. So if you differentiate on both sides with respect to phi, what you are going to get? Here you are going to get minus rho sin phi. So therefore dx is equal to what? Dx is equal to minus rho sin phi d phi. So this is dx, right? Next similarly you have to determine dy by varying what? By varying only phi. So if you determine dy by varying only phi, what you are going to get? So dy by d phi is equal to what? Is equal to rho into cos phi. The differentiation of sin phi is nothing but cos phi. So you are going to get dy is equal to what? Dy is equal to rho into cos phi d phi. Now here if you observe, z is independent of phi, so if you do dz by d phi, what you are going to get? 0. So therefore dz is equal to what? 0. Just substitute this dx dy values and dz values in this expression. So what you are going to get? Dx is nothing but what? Minus rho sin phi d phi ax cap, and dy is nothing but what? Plus rho cos phi d phi a phi ay cap, right? Ay cap, and dz is 0, right? Okay. So if you observe on both sides here, rho d phi will get what? Will get cancelled. So therefore what you are going to get? You are going to get a phi cap is equal to what? Equal to minus sin phi ax cap plus what? Plus cos phi ay cap, So this is the expression for a phi cap here. So minus sin phi ax cap plus cos phi ay cap. Understood? Okay. So now see here. So we got a phi cap. A phi cap is equal to minus sin phi ax cap plus what? Plus cos phi ay cap. This is what we got for a phi cap. right? Now for this also we can check here, for this also we can check. See here, we will check whether our expression is correct or wrong. Now see here, when phi is equal to 0, when phi is equal to 0, this x component term will become 0 and here cos phi will become 1. So a phi cap will become equal to what? A y cap. So when phi is equal to 0, this is the point. At this point phi is equal to what? Phi is equal to 0 degrees. So what is the direction of a phi cap? A phi cap is nothing but what? Tangent drawn at this point in anti-clockwise direction. So if you draw the tangent at this point in anti-clockwise direction, it is going to point in which direction here? A phi cap is pointing in which direction? It is pointing in y direction. So a phi cap will be equivalent to a y cap. Understood? That's what we are going to get or not? When phi is equal to 0, when phi is equal to 0, a phi cap will be same as what? Will be same as a y cap. Next, if you put phi equal to 90 degrees here, if you put phi equal to 90 degrees, so phi equal to 90 means this term, this y component term will become 0, cos 90 will be 0, sin 90 will be 1, here you are having minus, so you are going to get minus ax cap. So a phi cap will become equivalent to minus ax cap. So at this point, this is the point phi equal to 90 degrees. So at this point, if you draw the tangent at this point in anti-clockwise direction, it is going to point in which direction? It is going to point into the board, right? At this point, a phi cap is going to point into the board, right? So into the board means in which direction here? Negative x direction. See, positive x is coming out of the board, so into the board means negative x direction. So here a phi cap is equivalent to what? Is equivalent to minus ax cap when phi equal to what? When phi equal to 90 degrees. Okay, so like that by substituting phi value, we are going to get the direction of a phi cap, right? So here also you can observe that this a phi cap value is depending upon what? Is depending upon phi, So as phi varies, the direction of aero cap and a phi cap both are going to vary. Okay, and how they are going to depend upon phi, that's what we have determined. So aero cap we got it as cos phi ax cap plus sin phi ay cap. A phi cap we got it as minus sin phi ax cap plus cos phi ay cap. Understood? So if you are having any doubt here, here you can check in this manner. See, always we know that aero cap, a phi cap and az cap are mutually perpendicular to one another. We know this one, right? Mutually perpendicular to one another, right? So which means aero cap dot what? Aero cap dot a phi cap must be equal to what? Must be equal to 0. A phi cap dot az cap must be equal to 0 and az cap dot aero cap must be equal to 0. So here we have determined the expressions for aero cap and a phi cap, right? So if you want to check whether that expressions are correct or wrong, if you want to check, what you can do? You can do aero cap dot a phi cap and check whether it is becoming equal to 0 or not. So if it is becoming equal to 0, then our answer is correct, right? Okay, so aero cap, what we got here, if you want you can check this one. So cos phi ax cap plus what? Plus sin phi ay cap dot what? A phi cap. What is the expression for a phi cap? We got minus sin phi ax cap plus what? Plus cos phi ay cap. So you can check here, if you do the dot product, you are going to get 0. See here, cos phi ax cap dot minus sin phi ax cap is nothing but minus cos phi into sin phi, and sin phi ay cap dot cos phi ay cap is nothing but plus sin phi into cos phi. So if you add these two, you are going to get 0, right? So and hence our expressions that we got are correct, right? Okay, and if you want the magnitude of unit vector must be always 1, right? So if you want, you can determine the magnitude of aero cap, you are going to get what? 1. If you determine the magnitude of a phi cap, this is also equivalent to 1, right? Okay, so the magnitude of this term is 1, the magnitude of this term is also 1. So everything is valid, right? Next az cap direction is always fixed, right? Az cap direction is always fixed. It is it is always perpendicular to what? Perpendicular to, sorry, AZ cap direction is always fixed, and the direction of AZ cap is always parallel to what? Is always parallel to Z axis, right? So here AZ cap will be same as what? AZ cap will be same as AZ cap only, right? Okay. So this is how you have to represent the dependency of unit vectors on phi, right? Okay. So I hope each and everything is crystal clear. So okay then, take care, bye bye.